Hello, welcome to my YouTube channel. This is Ali Zabar, and I prepared some lectures on the learning and memory. The focus, I have to mention the fact that the focus of these lectures is on the cellular and molecular basis of learning and memory. So the motivation for these lectures comes from one of the TED Talks of Professor Eric Kandel, in which he said that the central challenge of neuroscience in the 21st century is to understand the human's mind in biological terms. And even before that TED Talk, I have been always fascinated by the neurobiology of cognitive faculties in the brain and in the human's mind, including memory, of course, language particularly, thinking, problem solving, and other cognitive systems. So, excuse me. So, I decided to share what I've already learned about the neurobiology of learning and memory with you. It's not much, of course, but I'd just like to share it with you, professors. I hope you enjoy that. And this lecture, it's a very first lecture in this series of lectures. It's just an introduction to some of the concepts that I'm going to elaborate on later. I'm going to define learning and memory, and then I'm going to talk about different classes and different forms of memory. Let's begin. Before defining learning and memory, I would like to appreciate the role of memory in our lives. Oscar Wilde says beautifully that memory is a diary we all carry about with us. It's so true. You know, our personalities, when you think about it, our personalities, our social interactions, our characteristics, many other aspects of our lives, they rely and depend on our memories and our ability to form new ones, of course. Other cognitive faculties in the human's mind or brain, like, for example, sentence processing or thinking or logical thinking or problem solving, and many other cognitive faculties and cognitive functions rely on some forms of memory to some extent to function properly. So memory has a very central role in our lives. So let's define learning and memory first. I want to picture a situation and define learning and memory based on that. Let's see, what do we have here? We have a happy cat. It's happy in its environment. We introduce two new things, two new stimuli in its environment. The first stimulus is the cat's food, representing a good one, a good stimulus. We have another stimulus called an electric shock, obviously representing a bad stimulus. Let's see, what does the cat do when we introduce each one of them in its environment. So we have a cat in our first scenario. We introduce the cat's food. Obviously, the cat, for the very first time when we introduce the cat's food, the cat goes for it, wants to discover what it is. Once the cat discovers that, oh, it's a delicious food, it's yummy, well, the cat goes for it, okay? And the cat enjoys that. It's obvious. The next time we introduce the same stimulus, the same food, the cat remembers something about the food. Remembers that the food was very delicious last time. So it doesn't hesitate anymore, and it goes for it. When we introduce, in our second scenario, we introduce an electric shock. I told you, representing a bad stimulus, a harmful one to some extent. It's a tactile one. But anyway, again, the cat, for the very first time goes and discovers, wants to discover what it is. But when it gets shocked, the cat turns away, doesn't like it, okay? So the next time we introduce the same electric shock, the cat says, oh, I remember that. That was a shock. Don't go around it. So the cat doesn't hesitate and go away from that. Let's see what happens when we introduce a new stimulus. It's neither food nor electric shock. What it is? It's by this new stimulus, I mean, it's a stimulus which is neither useful as the food nor harmful as the electric shock. So like the last previous scenarios, the cat goes for it, wants to discover what it is. Once he sorry. Once the cat discovers that this new stimulus has literally no value, what does the cat do? The cat goes away. Fair. We introduced the same stimulus again, which is not food, not an electric shock. What do you think the cat does now? The cat doesn't go for it. The cat remembers that the new stimulus, that the same stimulus is the same neutral stimulus. It doesn't represent any value. It doesn't represent any harm. The cat should not respond to that. Okay, should not waste his time to go and discover about it. This is how I want to see and I want to look at the learning and memory. Now let's define learning and memory based on the scenarios we had. Dr. Eric Kandel said in his textbook, Principles of Neuroscience, that learning refers to a change in behavior that results from acquiring knowledge about the world. We saw this change in the cat's behavior, and we saw that it was that change in the cat's behavior in three different scenarios. We saw three different behaviors. And we saw that each behavior was a result of some sort of knowledge that the cat gained from the stimulus, from the nature of the stimulus. So the cat, for the very first time, learned that the food is good, the electric shock is bad, some kind of a stimulus we introduced was neutral, and the cat literally changed its behavior toward that. For the food, it changed its behavior. It doesn't hesitate anymore when the cat sees food. It goes directly to that. When it sees an electric shock, it doesn't hesitate. It runs away. For the new stimulus, the cat doesn't do anything, and that is learning. But there is a process which allows the cat to remember something about those stimuli. And that process is the memory. So memory is the process by which that knowledge is encoded, stored, and later retrieved. And yeah, so we define learning and memory by those three scenarios. In each of them, the cat changes behavior, and the second time, or other times, the cat remembered something about that stimulus. So we saw the role of learning and memory. It's almost the same for us humans, but it's a little bit more complicated, of course. But the general basis, the basis is the same. Classification of memory. Neuroscientists use two criteria to classify memory. The first criterion is based on the time course of a storage. It's all about this question: for how long the stored information can be retrieved. If the stored information in your memory can be retrieved within minutes or days, sometimes, or hours, okay, it is encoded in your short-term memory, okay? Or working memory. I'm going to explain the subtle difference between short-term and working memory. But if the stored information is encoded, can be retrieved for longer times, even sometimes it can be retrieved throughout the life, it is stored in your long-term memory. So it's a very easy, very straightforward classification of memory. Another criterion used by neuroscientists to classify memory is based on the nature of the information stored in our memories. It turns out that different types of information recruit different mechanisms and different types of memory to be stored. For example, information about events and experiences. For example, the information about your 10th birthday or your wedding party is stored in a different way, in a different type of memory than, for example, information about facts, information about names of people, names of places, or definition of a word, and so on. Okay, so, and we have other types of information that are encoded in different types of memories. And it's another way of classifying memory. Let's elaborate more on the classification based on time. So we have long-term memory. Long-term memory is basically the type of memory that when we generally speak of memory comes to our mind. You know, it's it's called memory proper or secondary memory by William James, the father of American psychology. The reason it is called secondary memory, I guess, is that I think William James knew the fact that first we have short-term memory, and then the information stored in short-term memory is transferred to long-term memory. Okay, that's maybe that's why he called long-term memory secondary memory. But basically, it's a kind of memory that that is familiar. We are familiar with it, and as its name suggests, it's for storing information for long periods of time. The other one is the short-term memory, as I explained. It's a transient representation of information relevant to immediate goals. That's very important because sometimes, for doing a specific job, you want to store some information only for doing that specific task or that goal. After that, you don't want to do that. You don't want to remember all that stuff. Example of it, for example, when you cram at the night of the exam, you memorize a lot of different facts in a very short period of time. And all the information you memorized, you are going to remember them only at the time of exam, or maybe 1 or 2 minutes after the exam. After the exam, at least a day after the exam, all of that is going to be wiped out. Okay, that is short-term memory. We have working memory. Working memory is also sometimes, somehow like short-term memory, but in working memory, you're allowed to manipulate and organize the temporarily stored information. It's very important for other cognitive faculties and other cognitive abilities. That can be a reason that IQ tests also measure our working memories. But there's 3 subsystems working for working memory. The first subsystem is verbal subsystem. Its name gives us some clue. It's for phonological or speech-based information. For temporarily store phonological or speech-based information. For example, when I call someone, when someone gives me a phone number, I can rehearse the phone number within minutes. If it's very important, it's a very important phone number. If it's my it's a phone number of my crush, for example, I can remember it within days. But after days, I just forget it. The subsystem of working memory allowing me to rehearse that phonological based information or speech based information is a verbal subsystem. Visuospatial subsystem is another subsystem. Again, its name gives us some clues. Well, it's defined as the mental representations of objects. I mean, the shape of objects and their locations in a space, and the type of memory which allows us to remember that kind of information and temporarily store that and manipulate that kind of information is the visuospatial subsystem. There is, although, there's a third subsystem called executive control processes. The third subsystem, I believe, plays a very, very important role. First of all, it allocates attention. Because storing information in working memory, I think it requires a lot of attention and conscious attention. So the third subsystem allocates attention. It also plays another role, which is equally important. It monitors the temporarily stored information in the working memory, and it updates that information. Why is it so important? Because it turns out that the capacity of our short-term or working memories is very limited. So what executive control processes, the third subsystem does, is to monitor the information and update the information stored in our working memories, so there is a space to store new information. Okay, so that's why it plays a very important role. That's it. Sorry. Now let's talk about different forms of long-term memory. Long-term memory is a little bit more complicated than short-term memory. A lot is going on here, but well, there are two general forms of long-term memory: implicit long-term memory or non-declarative long-term memory. It's actually the unconscious recall of information stored in long-term memory. And we have explicit or declarative memory, which is the conscious recall. I'm going to explain what do I mean by conscious and unconscious recall of information. Sorry. So, subforms or subtypes of implicit long-term memory. Quick note. I'm not going to explain all of them. Yeah. So for example, priming, controlled by the neocortex. Procedural memories, memories related to our skills and habits, which are controlled by the striatum. A fun fact about memories memories related to skills and habits is that at the beginning of learning any skill or habit, we should consciously recall all the subtle movements or subtle information related to that particular skill or habit. For example, for the very first time that I want to learn how to bike, I have to pay attention to various subtle movements and so on, consciously. As I practice it more, as I master riding a bike, I can almost ride a bike unconsciously, okay, automatically, while I'm thinking about something else. Okay, so this is very important. So first, it's conscious. Then when you practice it and when you master it, it becomes unconscious. It's controlled by the striatum. Associative learning, for example, classical conditioning, going to explain the molecular basis and cellular basis in the implicit memory lecture. But for example, emotional responses is a type of classical conditioning. For example, classical fearing, is that a word? I don't know. Fears, for example, is a type of emotional response, and it's controlled by the amygdala. Skeletal memory controlled by the cerebellum. Firstly, we have also non-associative memory like sensitization and habituation. Again, there's a whole new lecture, so a complete lecture about how sensitization and habituation works. They are controlled by reflex pathways. So these were subtypes and examples of implicit memory. Implicit long-term memory. Let's talk about explicit long-term memory. Explicit long-term memory is a conscious recall of information stored in your long-term memory. For example, I can consciously recall what happened at my 10th birthday. You know, I can consciously recall and access that information. So that's what I mean by explicit memory. There are two general forms. There's an episodic one, related to events and experiences. And there's a semantic one related to facts, such as the definition of a word, for example, names of places or people. Yeah. And they're controlled by the medial temporal lobe, as well as the hippocampus. Hippocampus also plays a very important role in explicit long-term memory. Okay, here you see those anatomical structures important for working for storing implicit memory. You know, for example, the neocortex, the striatum, the amygdala, cerebellum, reflex pathways for sensitization and habituation. And in the picture on the right, you can see the medial temporal lobe, two of the most important structures for explicit memory. Medial temporal lobe here, and the hippocampus. Hippocampus also plays a very important role in explicit memory. Okay, that was it. You know, after this lecture, I plan to go directly to implicit and explicit memory and explain them. Then I realized that when I was studying for those lectures, when I was learning about the neurobiology of explicit and implicit memory, I realized that many of those cellular and molecular aspects of those two types of memory, they're related to signaling or communication between cells and between neurons. So I decided to present some lectures on biosignaling, okay, in which I'm going to explain the principles of biosignaling and some of the concepts which are relevant to the neurobiology or the cellular and molecular basis of implicit and explicit memory. So the next couple of lectures are going to they are related to biosignaling, okay, and and then I'm going to explain implicit and explicit memory and the cellular basis of those types of memory. Thank you so much for watching this video, and I hope you can watch other videos too. Yeah, that's it. Thank you.